Okay, so this question's talking about cumulative frequency. So a few key facts that we need to make sure we're clear of. Cumulative frequency, we always plot the end of the interval against the cumulative frequency. So here's the ends of the intervals. And we need a cumulative frequency column. Well, this question's been generous. It's already drawn it for us. If not, then we'd have had to have added an extra column on and added up the frequencies that they might have given us. And the thing to recognise with cumulative frequency graphs is that all cumulative frequency graphs, the graph itself must be continually getting bigger and bigger and bigger. If your graph does not continually increase, then you're not doing cumulative, which means add up as you go along. So it's adding and adding and adding. So therefore, we'd have a cumulative frequency graph that does that. So the plotting of it, then we're going to take each of these numbers, 10 against 8, 20 against 21, 30 against 46, 40 against 67, 50 against 76, and 60 against 80. And therefore we're going to plot them and end up with this kind of effect. So we'd end up with the plot points there. Now what we've got to remember about this type of graph is that it continually goes up and up, and when you draw them you must start the smallest of the values possible, which was 0 in this case. So we're going to start at 0, and we don't take our pen off, or you should be using black pen of course in exams now, and you must go through every cross, continually getting up and up and up. So that would be our cumulative frequency graph drawn, continually going through every cross, up and up and up. Now the question asks us to draw that, so that's done. So it should get 2 marks for that bit. It then talks about the highest mark and the lowest mark, and it wants us to draw a box plot. So what we've got to remember about box plots is that box plots have 5 values that are needed, and we end up with a drawing that looks something similar to that, where the bottom value is the minimum value, this end of the box is the lower quartile value, the quarter way, this value is the median, and the end of the box is the upper quartile value, 3/4 of the way along our data, and the last value is the maximum. So we need those 5 values. Now they've given us 2 of them already, so we need to find the lower quartile, the median, and the upper quartile, and that's why we've got the graph. And the graph then allows us to find those values by reading off. So the median, well, there was 80 values in here because the cumulative frequency finished at 80, and that halfway of that would be the median. So we come across from 40 and we come down to the axes at the bottom and we read off our value there, and we find it's 28. So our median equals 28. Now yours might be slightly different when you draw this on your own graph because it depends on how you've drawn your freehand curve, but as long as you're around 28 then it shouldn't be too bad. Now the lower quartile value is 25% of the way along your data, so there's 80 data points, 25% along the way would be a quarter of that, which is 20. So we come to the graph because everything's read off the graph, that's the point of drawing it, and we come down and we find that the lower quartile value is 19 in this particular case, and the upper quartile value is 3/4 of the way, and 3/4 of 80 is 60, 1/4 being 20, 3/4, 3 of those, so 3/20 to 60, and we come down and we read off the value. So we find that the upper quartile value is 36, so the upper quartile value is 36. Now it's important you don't just come straight down and put those values on this graph because it's about scales. Now we can see that the scale here is slightly offset from this one, so it's not a case of just going straight down. Be careful you read the scales to plot properly. Now they said in the question that the lowest mark was 9, so we can put a dot at 9. Then we've worked out that the lower quartile was 19, we've worked out the median was 28, we've worked out the upper quartile was 36, and they told us the maximum value was 52. So now we can draw the picture we expect to see. So from the ends we come in with a line, and then we draw a box around our quarters. And then draw a line through the median. And traditionally we put little dashes on the end of these just to finish off the box plot. So that's our box plot drawn for marks 1. So that should give us 3 marks for that bit. So we've done that bit. Now the question goes on to say compare the marks. So now we have to do the compare the marks. Now whenever you're comparing data, then you should always think of an average to compare. That's a measure of location. typically what states untypical about your data, and you should always talk about something to do with the range and spread. Now, with box plots and cumulative frequency graphs, you really should be talking about the interquartile range, which is calculated by doing the upper quarter value take away the lower quarter value. So for our box plots, we found that the lower quartile value was 19 and the upper quartile value was 36, and 36 take away 19 is 17. So for paper 1, so let's get some values down so we've got something to compare. So paper 1 and paper 2. So the interquartile range was 17, and the median average, because the average that you're dealing with on the box plots is median, so the median average we found was 28. And for paper 2, I'll read off the graph. So the lower quartile was 17, the upper quartile was 41. Take those away from each other, you get 24. So the interquartile range for paper 2 was 24, and the median average we read off was 32. So the median average was 32. Okay, so we've got our values then to start thinking about how can we write the comparison. Now it's a starred question, remember, so it's really important that we write something that is in context of the question. So we're comparing the marks, so we must talk in terms of marks. So what we're going to say is something like on average students did better on paper 2 as the median average was higher. However, on paper 1 the marks were less spread out as the interquartile range was smaller. So we can see that the interquartile range was smaller for paper 1, which shows the marks were less spread out, they were more consistent. And for the median average, it suggests that paper 2, typically the students did better on there on average. So that would give you the 2 marks, because you're comparing the average and a range, and you're talking about it in context about the marks and how they were worked out. So it's not just a case of simply saying that the median average was higher. This is a compare question, starred question, so we have to have a sentence or two with some explanation of what the data actually means.